morning, good afternoon, and good evening, everyone. My name is Divi, and I'm here to show you an end-to-end additive manufacturing workflow within Fusion 360 today. The aim of this session is to do everything within Fusion 360, where we're going to start from the design point of view, specifically generative design, where we're going to create a part for additive manufacturing, following which we are going to get it set up for metal additive manufacturing using Fusion 360's manufacturing workspace, and also plan for its post-processing, which is in this case turning, but for basically the subtractive operations where we finish the part for its final use. To begin with, let's have a look at the design that we're working on. Some of you might have noticed or seen this in the last couple of weeks or months. There's this new story going around of Porsche making their piston heads with additive manufacturing. That was my inspiration for this session. We are going to go through the steps to recreate exactly what you saw in that news story with Porsche. Although full disclaimer, that had nothing to do with Autodesk. I'm simply using that as an inspiration to recreate it and see how we would get the job done. So what you have is the geometries defined and created for a generative design setup. If we get into generative design, you would see that they have been marked with the right obstacle and preserve colors. So these are your preserves and this is your obstacle. This is the area at which your piston head would then need to connect with the crankshaft at the inside of your engine block to work. You will notice that I have a bunch of previously solved studies over here. We're not going to solve a new generative study during this session because that's going to take some time, so I've already solved them up. And what I had done was I was experimenting with different starting shapes. One of them is this that you see over here. And that gave out different outcomes, as you will see with these different studies. However, at the end, I realized that simply using preserve and obstacle without any starting shape gave the best outcome for additive manufacturing using generative design. Everything else was forcing the design to be a lot more conventional, not really made for additive. And in some cases, it also made some pretty good outcomes for die casting, for example. But that's not what we were looking for. We were going for additive manufacturing, and hence we're simply going to have obstacles and preserves. There's no starting shape. I don't have any symmetry too. I was just trying to give it more freedom to come up with something. And the only final thing I would call out on is the loading conditions or the boundary conditions that I've applied over here, which count not just for the pressure that is applied on the top of this, or the head of this piston head, but also the extreme cases of a very heavy bearing load should something get stuck, and also if there were to be extra friction, what can happen when on these surfaces that might push this part inwards of sorts. We are looking for minimizing mass, and we are looking for the additive outcomes, which also would mean having a look at the unrestricted outcomes. So the previously completed studies, as I mentioned, explored a lot of different design spaces. Some of them were making some pretty good die-casted outcomes. Some of them were making some really stripped down additive examples, like these might work for additive, but I didn't think that they were structurally sound. Neither were these, which just have these really thin beams connecting across. And finally, after the final setup that you see that resulted in this was the outcome that I picked, which is this one over here. I'm not going to go through the complete selection criteria and the process that I went through for this part. My goal over here was to focus more on manufacturing. So let's get started with that. Let's open up the design and get it ready for manufacturing, first with additive and then for completing its post-processing with subtractive. Here we have the design, and you will notice that there are some little knobby surfaces. This happens very commonly with the BREP creation from generative design. And in case you would like to have a deep dive into how to deal with the form workspace and improve your BREP design, I highly recommend a session that's been conducted by James Neville on this topic. It's also being hosted within this Advanced Manufacturing Summit with one of the additive tracks. However, in this case, I'm simply going to change certain things within the boundary fill function. Not going to go into a deep dive. And what does the boundary fill function do? It's a good way for you to combine open forms and surfaces like you see over here. All these surfaces that have been made, along with solids, which were the preserved regions that you would have created upfront. And I'm simply deselecting the open forms and surfaces I don't want to be considered for creating the final geometry. So you'll see that I simply don't want these extra knobby surfaces, and I'm just deselecting them. And that should bring me back into just the generative surfaces that I'm interested in. Oh, there is a little patch of surface still left, and that's fine. I'm going to go back into boundary fill to remove it. I'm simply going to select it all and hit the delete button to get the job done. Now, this is the part that we need to make, but this is going to call it the final outcome. This does not really have to be what we need to print. What you pass into printing, bad spelling. What we need to pass into printing can be a lot more simplified. For example, and let's start working on it together by simply copy pasting this, and let's call this the additive outcome. For the additive, we can extend this by an because we don't need to add support structures to the bottom for this, something that is going to be flat anyway. You can simply choose to put it down on the build plate, and to do that we need to account for some extra material that that can be cut away. So 1 mm down there should suffice. We also don't need to have these grooves. They're like really small grooves, which I think are just 1.2 mm apart, and they can be something that will be machined away later, and they're actually preferred to be machined away. So let's simply close them up too, as they are features within the geometry which are not necessary for printing, but more necessary for the final outcome, which can be machined. Repeat the extrude and get things done over there. And one could also say that these surfaces need to be machined away, so let's make an offset for them too. An mm of offset, and similarly an mm of offset over there. This is for, yes, I think I need to add an mm. We could also close these holes up if you want to, but that's fine. We'll simply remove support structures from them, and they'll be drilled away later anyway. We don't really need to print so much extra thickness over here. That is not necessary. We'll simply support them. And that's it. So that would be our setup that needs to be accounted for the final outcome. Oops, I seem to have made a mistake of doing all my operations on both the geometries. So that means I now have everything joined together. That is my bad. We need to make things as new geometry so that yep, even my name change did not stick. Funny, I don't know why. So let's rename that to additive outcome, and we need to simply boolean these things together with these two so that combines, and then we get the final outcome. So we have the final outcome and the additive outcome. The final outcome is what we actually need to use. That is what will be printed and machined, and this is what we simply need to print. Okay, now let's get on with the manufacturing setup. I would like to call out at this point that what I'm going to do is metal additive manufacturing setup first. So I'm going to select my machine. Let's pick the Renishaw machine because I like working with that. It's important to note that this machine would only be available once you have selected the manufacturing extension or kind of subscribe to it from here. By default, Fusion only has the FFF machines within its additive workspace. Should you want to have the metal machines also, you will need to subscribe to the manufacturing extension, which I've already done in this case, and hence I could select the Renishaw machine. It's printing in aluminum, that's fine. It's doing the automatic placement, that's also fine. The only thing that I would change is I would put this down on the build plate because we have already added offset over there. Don't need to have it floating and the bottom surface supported. I don't really need to orient it because this part was made with the additive constraint in head, so we know that it needs to kind of grow and bridge up these gaps. We don't really need to orient it or turn it in any other way. The only thing that we now need to do is add support structures, and we're going to add some volume supports. We're going to add supports to this entire body. So I'm going to go there and select the entire additive outcome as something that needs support. And just for the sake of doing things a little bit better, I'm going to say that make these two things as not supported, because we are going to add some special support structures there, something that's a lot more dense. Everything else, these little areas which might need support, just these small gaps that you see, we're going to support only those with this support action. And I'm going to do that by keeping it structured. Yes, that's what we want. We want it to be a punch plate. We want it to be sparse. We want everything to be as sparse as possible, because we don't really care if that bit is really well defined, because it's only going to be very basic supports. Breaking point everywhere, that's good. And we will have support structures created for everything except the holes. Now, why did I choose not to have support structures within the holes? That's because I would like to create more dense support structures over there, something that's going to be a lot stronger, purely because that is a more important area for me. I know that I don't want any problems in that area, and I simply want things to be stronger there. So I'm just defining everything pretty much similar to what I did in the past, but I'm just making it stronger. Like my fragments are smaller so that they don't have large fragments, so they're all densely packed together. I have my density of the structures to be dense, and I'm going to keep the top part and bottom part connection to be strip, just to keep them extra well defined. And that should soon complete. There we go. That's like more densely defined support structures in that area, a little bit more sparse on the outside. That looks good. I can now go ahead and create my tool parts, and after that I can continue to process my machine ready file. But while that is happening, I can now start to work on my next setup. What is my next setup? That was meant to be for turning, because we need to machine this part. So I'm going to pick my turning setup, and I have some machining to do on this end too. So I'm simply going to say that my chuck is on this end, so the part is going to be held over here, and then all the machining operations will happen from this side of things. I will need to ensure that I'm selecting the right stock body and the right model body. In this case, the body which we need to create is the final outcome. It's not the additive outcome. The additive outcome is actually something that is going to be consumed as the stock. So we go into stock and change it from the fixed size cylinder to a solid. And the solid is our additive outcome, because that is what we're going to give to the machining setup to start processing. There's no other changes that I need to make. It's all fine. I'm going to click OK. And we can now proceed with the the turning setup. One of the great parts of working like this on Fusion 360 is that you can see that my additive toolpaths is still getting calculated, but I didn't really need to wait for that job to be processed. I can proceed with the next of the steps. I'm first going to remove this extra mill of material that we had offset from there. I'm going to do a face turning operation by selecting a tool. Let's go into the turning sample tools. Since I don't really have a specific machine in mind, I'm just dealing with everything as a sample point of view. Are just basically defaults, So we have that selected. We know that we need it to be done from the front. That's correct. The clearance and the geometry that it needs to work on, it's also correct. Nothing much to change over there. We needed to complete it with no stock left behind. That looks okay. And if I were to simulate this, you can see that it will just simply go there and remove that extra mill of material that we have added. All right, now let's go ahead and change this profile. That's like this outer profile that we have. I can choose to do it as a roughing or finishing. I'm simply going to pick finishing because it's just the last bit, like the last millimeter that's left behind. It's not that rough an operation that I'm trying to do. I'm going to select the same tool. The same tool is fine with me. Not going to change much. It was anyway selected from the previous setup. Everything else remains the same. Let me just give it just a little bit outer clearance and let it do it in step overs of 0.5. And I don't need to make it do any grooving because the grooving is something that we can do as a separate operation with a specific tool. We don't need to leave any stock behind. Click OK. Oops. That's the wrong option for me to change. This is what I wanted to change. And that's done too. It's given me a warning. The lead out had to be modified so that it does not enter into the stock. Fair play. I should have selected that. And it's good to know that that change has been made for me, so I don't have to worry about it. I seem to have set it up so that it's missing this little step in. So I think I need to go ahead and change the toolpath. Give it a little bit more gap to work with. Front to back, everything is fine. And I think I'll just allow it to do the grooving so that it does not, it tends to pick it up at least, which it will now. Yep. Okay. Okay, that seems to be taken care of. We can now proceed with the final grooving operation to make these two grooves. And for that, we are going to select a new tool because the previous tool will not work. That's not a grooving tool. I am going to pick the OD grooving tool, select that. This is also a little bit too large, so it is best to reduce it to something that actually can fit into the groove. We do that by changing or editing the preset that we have picked. Now I'm simply making these changes to reflect the size of the groove that I need to machine. Ideally, you should try to work with a tool that you know you have access on your machine. I don't really have a machine in mind, and hence I'm making these assumptions that I'll be able to get a tool that's going to be doing what I'm typing out over there. Okay, I accept that, select that. Cool, that is a new tool that we'll need to go in and finish up these grooves of 1.2 mm, and hence I selected its width to be 0.6 mm. We'll keep it to same in the geometries. I will keep it to the same in terms of the clearance and the outer and inner radius it needs to work with. This has to be 0.6, and my step over also has to be 0.6. There's no stock to leave behind, and that should be that. And once that's done, you'll see that it's going to be going into the groups and running the simulation on that will show it. Okay, that's done too. And with that, we have completed the machining setup also. And at this time, we have also managed to complete our additive setup. I could create the post for this and post it out to my turning machine for this to be milled. And at the same time, I can also post out the Renishaw slice stack for that machine to consume and start to print the part. So there you have it. It was an end-to-end additive manufacturing setup completed 100% within Fusion 360 with all the operations accounted for within the tools of the design workspace, the generative design workspace, and the manufacture workspace. Thank you for joining me for this session. I hope you have found it useful. I hope it's given you a bunch of more ideas of how to deal with complicated setups just within one single tool and a single platform. I'll be around after the session in case you guys have any further questions or any extra details that you would like to ask me. Thank you for your time and see you around.